In this video, we're going to look at where the equation for a parabola comes from. And first off, a parabola is the set of points, which is represented by this black line, that is equidistant from a single point called the focus and a line called the directrix. What that means is if I choose any point on this parabola, any point, we'll call it xy, some random point, I know that it will be the same distance from the focus, so from this line right here, from the focus to that point, is going to be the exact same distance as that point to the directrix. And that is what creates the parabola. Now let's see where the equation comes from. Well, we know that the focus is the same distance to the parabola as the parabola is to the directrix. So these have a common distance. We're going to call it P. So the directrix is P units away from the vertex of our parabola. That makes the point here, the focus, P 0 comma P. That makes this point here, whatever x is, because it's going to be in line with this point, comma negative P, because every point on this directrix has a y value of negative P. Now, this distance should be the same as this distance. Well, what we're going to do is set each of these up with our distance formula, and then we'll set them equal to each other. So let's do this piece here first. Distance formula says it's the square root of the difference in the x values, so 0 minus x, the quantity squared, plus the difference in the y values, p minus y, the quantity squared. Now that's going to be getting set equal to the distance here. So the difference in the x values in this case is x minus x. So x minus x squared, which is going to simplify quite nicely. And then y minus a negative p squared. So y minus negative p squared. So what we need to do is simplify that. First thing we're going to do is get rid of the radicals by squaring both sides of our equation. So that'll get rid of our radicals. And let's start to simplify. This is 0 minus x is just x squared plus p minus y, the quantity squared. Over here, x minus x is 0, and that's just going to become y plus p, the quantity squared. Now, these need to be FOILed out. Yes, you'll get the same answer even if you distribute the square, but that's mathematically not correct. So x squared plus this one here is going to be p squared minus 2py. Actually, it won't come out correct, sorry, if you don't FOIL this out. Plus y squared equals y squared, because you'll be missing these middle parts, plus 2py plus p squared, which is the most important part, actually, in solving this. Alright, now, if we subtract p squared off of both sides, those will cancel. And if we subtract y squared off of both sides, those will cancel. So last thing I have to do is I'm going to add this 2py over to here, and I get x squared equals 4py. Now there's a couple different ways that you'll see these solved. This is actually pretty standard for a quadratic. Now, one thing that you'll see some people do is they'll solve it for y, because then it's going to make it easier for us to graph. If we decide to do that, I'm going to write it over here because I'm going to come back to this in a second. The equation for this quadratic here we might write as y equals x squared over 4p. And sometimes you'll see it written as ax squared, and in this case a equals 1 over 4p. Now there's some really cool properties about that 4p. Well, p we know is how far the focus is from the vertex and how far the vertex is from the directrix. 4p is actually the width of the parabola at the focus. It's actually a pretty neat little property. So this will work for any quadratics centered at 0, 0. Now let's talk about how we move that quadratic to have another vertex. What if we want to move it right by h units and up k units? So maybe we want our vertex to be at h comma k. Well, if I want my vertex to be at h comma k, that's going to be the point when I plug in h and k that I should get them equal to each other. So remember what we do to move points. This would become x minus h, the quantity squared, equals 4p times y minus k, the quantity squared. Now, your first reaction might be, well, wait a second, you shifted it up. Why isn't it plus k? Well, you got to think about how we're doing these transformations and how this is a setup. We're not looking at it as a function of y as a function of x like we are here. So, for instance, y equals a times x minus h squared plus k. This would be the equivalent to this, where I'm using a to represent 1 over 4p and a vertex at h comma k. Shifted right h units, up k units. Now, making it look like this, notice what we'd have to do. We'd have to subtract k off of both sides. So I'd have y minus k equals a times x minus h, the quantity squared. And then I would divide by both sides by a to put the a over there. But that's why we get the y minus k term. So this is going to give us a parabola with a vertex at h comma k and what's called a focal length of p, which is how far the focus is from our vertex. Now this can be shifted up and down. We can have one that opens right and left by, I didn't mean to put a square there. That's my fault. We can shift this. This could be opening right or left if the y minus k is squared instead of the x minus h. We could also have this one coming down if the p is a negative. So a lot of things we can do here to get our different parabolas.